Hello, everyone. Today we're going to talk about perpetuities. So, what is a perpetuity? A perpetuity is an annuity with an infinite term. So, we have an annuity. Sometimes we have a finitely many terms, for example. Say you have 0 here, 1 and 2, and so forth. This is n. And you have payments, periodic payments, little p. So, this is a annuity immediate. We have a sub n angle I. Well, it's p times because the payment is not 1. And we have a p times s n angle I. And the formula for a sub n angle I is 1 minus b to the n over I. And now we have n going to infinity because we have infinite terms. Well, I mean, infinite terms, infinite many payments. So we're going to let n go to infinity. V equals 1 over 1 plus I. You raise the power by n when n goes to infinity. So v to the n goes to 0. So we have the present value of a basic level annuity immediate is 1 over I. Okay, that's the formula. It's 1 over I. The notation is this. And similarly, for the basic level annuity due is 1 over D. Okay, so that's the basic formula. We don't consider the future value because there's no future value. All right, let's look at a bunch of examples. Mr. Larson has saved $20,000. On January the 1st, he purchases a perpetuity with an annual end of year payments. So it's due, it's immediate, gets immediate. The perpetuity price is based on annual effective interest rate of 5%. This is I. What are the annual payments for Mr. Larson's perpetuity? So we're looking for little p. The formula A sub infinity I, yeah, p, okay, that equals $20,000. That's given. But the left side is p over I. So p equals I times 20,000. That's 0.05 times 20,000. That is 1,000. Okay. Next. Norman wishes to leave an inheritance to 3 charities. The total inheritance is a series of level payments at the beginning of each year forever. So let's call it little p, okay, the payment. He wishes charities A and B, which support medical research, to share the payments equally for 10 years. And then all payments revert to a charity C that helps needy children. If the share received by all 3 charities have the same value at time of the bequests, find the annual effective interest rate I. There are a lot of unknowns. So let's see if we're able to set an equation and cancel out all the unknown information and try to solve I. Okay. So first of all, the present value of A and B for charities A and B, they should be the same. Okay. So what is the present value of charity A? P is the total amount paid to all these A, B, C. So for A, uh, it's the total. Okay, P is the total, but A and B share the payments equally for 10 years. So for A, we have a payment P over 2, and it's annuity immediate because it's the end actually sorry, at the beginning of each year. So this is the annuity due. For A and B, they have 10 years. So we have A, two dots, 10 years. I don't know. We're going to try to figure out. So this is the present value for charity A and charity B. And for C, it's kind of deferred uh, perpetuity. Okay. So it would be P over D, but that is the present value at time 10. So you need to discount back. So you need to multiply by 1 plus I to the negative 10. Okay, so that's the present value at time 0. Okay. So we set them equal. So P over 2 times 1 minus 1 plus I to the negative 10. So it's V to the 10 over D. And that equals P over D, that's the perpetuity, present value of the perpetuity due at time 10. Then you need to discount back times V to the 10. We have a lot of cancellations here, so look at P is gone, D is gone, and I would have a 1 minus V to the 10 equals 2 times V to the 10. So I get V to the 10th, that equals 1/3. Okay. And V to the 10 equals what? It's 1 plus I to the negative 10. That equals 1/3. And we can solve for I from there. Okay. So the answer is given by this number. Okay. Next example. And the present value of a series of payments of 3 at the end of every 8 years forever is equal to 9.5. Calculate effective annual rate of interest. So we're looking for annual rate, but this 3 something 3 at the end of every 8 years. So we sort of need to, well, we wouldn't be able to find J, I guess. J is the effective rate for 8 years. And then we can convert back to I. So it's at the end, so it's perpetuity immediate. So 9.5 is the present value that equals 3 over J. So I have J equals 3 over 9.5. And then we have this conversion. So I equals 1 plus J to the 1/8 minus 1. And we get 0.0349. Okay. Next one. A perpetuity pays $1 at the end of every year plus an additional $1 at the end of every second year. The effective rate of interest is I 0.05. find the present value of the perpetuity at time 0. So let's draw a timeline for the sake of illustration. 0, 1, 2, 3, 4, and forever. And $1 at the end of each year, and then another one additional $1 at the end of every 2 years. So something like that. We can work with sort of two ways, but let me show you the way I would like to do is to figure out the present value of the cash flow of $1 each year. So let me use different color. So I have a one, one, one. So that $1, okay. And then I have a yeah, that orange is okay. Okay, so I have a sub actually a sub perpetuity. Okay, it is the end of each year, so it's immediate. I 0.05, and then we can work with the additional one, which is a sub infinity angle, not 0.05 anymore. Okay, it's 1.05 squared minus 1. So this is our J for 2 years. It's the effect rate for 2 years. So J equals 1.05 squared minus 1. That equals 0.1025. And then we add them up. Okay, we can do that. The answer is, so this is 20. Let's work one more step. That's 1 over 0.05. That's 20. And this one will be 1 over 0.1025. That's 9.756. And add them up, 29.756. Okay. Another way, it's a little bit complicated. So let me just briefly talk about it. So another way is you treat something like 2 here, and 2 here, and 1, 2, and so forth. For the cash flow is $2. That is 2 times a sub infinity angle J. J is 1.05 squared minus 1. Okay, it's 2 years. And then the other one is for $1, but you also have a 2-year jump. Okay, so it is 1 a sub infinity, also J. But if you discount back, this actually it's the present value at this time, okay? Because it's the distance between these two payments will be 2 years, so you need to go back like 2 years, 2 years from 1, so which is kind of -1. Okay, so in order to get the value at time 0, so you need to actually multiply this by 1 plus I times 1.05. You can check that these two should be the same. All right. Let's move on to the next problem. John uses his retirement fund to buy a perpetuity due of $20,000 per year based on an annual nominal rate, 8% compounded monthly. Find John's retirement fund. So we need to figure out the annual effective rate the uh, from the nominal rate 8%. So 1 plus I, that equals 1 plus 0.08 over 12 raised to the power by 12. Our I equals 1 plus 0.08 over 12 to the 12 minus 1. Okay. This amount, what is that amount? About 0.083. 0.083. Now we are looking for the present value. It's due, so the present value equals 20,000 divided by D. D, this is usually I would do. This is it's the present value of the perpetuity immediate. Then you multiply by 1 plus I. Okay, they always have this relation. The two dots is the same as 1 plus I times the value without two dots. So we plug in 20,000 over 0.083 times 1.083. It's 260,965.4. Okay. So my value is a little bit different from the value given by the solution, the answer given by the answer. The reason is that we have this I, which is slightly bigger than that one. Okay. And this number is on the bottom, so sometimes a small difference would possibly yield a relatively larger discrepancy. Okay. All right. Do I have, oh, that's all. Okay. All right. So next section is about deferred annuities. Sometimes we have an annuity which will be starting like several years later, or perpetuity that will happen some years later. So it's not really a new thing. The principle will be the same as what we discussed earlier. So I just need to be careful, very careful about the time. Okay, the time when these payments happen and how many payments, how many time periods the annuities was deferred. So that kind of things are very important. You need to be careful with details. All right, so let's have a look at an example. On her 18th birthday, Letitia receives an annuity that is to pay $5,000 on her 25th through 39th birthdays. Calculate the value of the annuity on her 18th birthday using an annual effective interest rate of 5%. On her 50th birthday, on her 30th birthday. I recommend you to draw the timeline. It will make the problem easier to analyze, I think. So time 0, it's her 18th birthday. And then we have a 25 So that should be 7. Okay. And then you have a 26, you have a 8 on her 39th birthday. 39. That is 21. Okay, 21. So I have we have 5,000 here, 5,000, and then 5,000. We're looking for the present value at time 0, which is 18th birthday. The other two, we're going to talk about them later on. Okay, just work on the first problem. Okay, so let's figure out how many payments do we have. Okay, and that's 39 over 25, which is 14, but you need to add 1. It's always the counting thing. You need to add 1. Okay. So usually when we talk about counting, I ask people to count how many numbers there are from 3, 4, and to 103. Okay. You subtract 3 from 103, you get 100, but you need to add back this number 3. So actually there are 101. There are 101 numbers. So the formula is 1 minus 3 minus 1. You need to add 1. Okay. All right. So when you look at this 15 payments, you can work with this value, the present value, or you can consider it as annuity immediate. Then you need to work with the time at 26. Okay, either way is okay. Sometimes I'm prefer using annuity immediate. So let's work with 24, but the other one is certainly okay. So here we have a 6 periods. Okay, that's something you need to sort of be 6 periods. 1, 2, 3, the 6 of them. 6 periods. N equals 6. Maybe I should use M. It doesn't really matter. But here you have N equals 15. Okay. So the formula is like this. We have a 5,000 times a sub angle. You have 15. Interest rate is given 0.05. So that's pretty easy. It's given. And then when you discount back to time 0, you need to multiply this quantity by 1 plus I to the negative 6. So this value is 5,000 times a sub 15 angle 0.05 times 1.05 to the negative 6. So that's the value we're looking for. And then we worked it out. So 5,000 times 1 minus 1.05 is 1 plus I to the negative 15 over I, which is 0.05, then multiply by 1.05 to the negative 6. This value is what is 38,727.30. Okay, this value I believe it's 51898.29. All right. You can do obviously using annuity due, that's totally fine, but essentially it will be the same. So let me use different color. So you're gonna work with that thing. So it's annuity due. You have 5,000 times, not times, a sub of 15 0.05. And then when you discount back to time zero, you actually have this quantity. Then times 1.05 to the negative 7 because there are 7 periods when you discount back to time zero. Okay. This is exactly a without two dots times 1.05 to the negative 6. Okay, because this quantity equals the annuity immediate, and then you multiply by 1.05. But then you have 1.05 to the negative 7, so you cancel one of them, you get 1.05 to the negative 6. Okay, so this is the present value at her 18th birthday. So on her 30th birthday, 30th birthday is somewhere here, 30. So you have 30 here, and that is actually 12. So this number is 12. So you have 12 time periods. So this is a this value, okay, 382727.30 times 1.05 to the 12. And for 50th birthday, that will be this number times 1.05 to the is 50. It's 50. You have a 32. So you have a 32 here. This number is 184,533.33. And this number is $69,548.67. Okay. You need to be very careful about how many time periods your discount back and so this kind of thing. Okay. Okay. Yeah, I think they are the same. All right. Let's look at another example. Marlene received a gift of a 30-year annuity immediate on the day she was born. The annuity pays $1,000 on her first 10 birthdays, $2,000 on her next 10 birthdays, and $3,000 on the following 10 birthdays. If the nominal rate of interest is 5% convertible quarterly, find the value of the annuity on the day she was born. Okay, again, I think timeline will be very helpful. So time zero is when she was born. On her first 10 birthdays. Then we have 10 birthdays, 20s, 30s. Here is 1,000. Okay. 1,000. 1,000. Starting from 11th birthday, she got 2,000. And then have 2,000. On her 21st birthday, 3,000. 3,000. Okay, so this is the timeline. All right, now we're kind of clear. Oh, actually, we need to figure out I. This is nominal rate, convertible quarterly. So 1 plus 0.05 over 4 to the fourth minus 1. That is our I. Okay. You calculate it out, and it will be saved in some C in your calculator because you want it to be very careful. You, you don't want it to only save like 2 decimal points or 3 decimal points. Then the uh, the rate is not very accurate. Well, and it would be possible to make some quite large error in the end. So you need to keep more decimal points. These quantities are, especially the present value, you have I on the bottom of a fraction. So it's very sensitive to the interest rate. That's why in stock market, when the interest rate is changed a little bit, but then the price of the stocks will change a lot. Okay, so let's set up the solution and then find it. There are two ways of doing that. One way is just separate three annuities. So I have a $1,000 times a sub 10 angle I is here, so I'm not going to put that number here when we set up the solution. And then I have 2000 times a sub angle 10I. This value is this one for this part of annuity. Okay, that's something you need to be sort of careful to understand it. And then you need to discount back at time 0, so which is if you do multiplying the 1 plus I to the negative 10. And then finally, we deal with the last part of annuity, 3000 times a sub 10 angle I. And this quantity is the present value of this quantity at time 20. So you need to discount back 1 plus I to the negative 20, then you will get present value at 0. So add them up. Okay. The answer is 25575.19. Another way of looking at it, it's very similar, but I sort of breaking up this 2000 by 1000 plus 1000. So I would have 1000 times a sub 30, because total you have 30 payments. So 1000 in 2000, in 3000, they are already taken care of. Okay, I think I forgot 0 here. Then I'm going to deal with another 1000 times a sub 20, okay, I, and then you multiply by 1 plus I to the negative 10. And finally, 1000 times a sub 10 angle I times 1 plus I to the negative 20. Okay. So let me explain a little bit more. So originally I have this annuity. Okay, so I have a 2000, 2000, 2000, 3 actually. So what I did was I separate them into the following. So I have 1000, 1000, 1000, and 1000, and 1000, 1000, 1000. Okay, and then I have so yeah, because 2000, so I'm gonna put another 1000 here, another 1000 here, another 1000, another 1000. So these 2000s were taken care of. And then eventually you have another 1000. Sorry, it's a little bit squeezed here. So 1000. So you add them up, you get 3000. You add these up, you get 2000. Okay. And then this quantity is for the annuity with 31,000 payments. And this is for the 20 1,000 payments, and then you have a 10 1,000 payments. Okay, they should give you the same answer. There are many problems like this in terms of dealing with deferred annuity, but in principle, they are pretty simple. You just be careful with the time periods and an annuity is deferred. Um, I think that's about it. Uh, so I'll see you the next time. Bye bye.